Finding the Friction Coefficient, Physics 2C Lab by Ella Kopich, Lily King, and Beatrice Milnes. Our purpose was to design an experiment in which we had to find an equation to find the coefficient of friction between any two surfaces. We used a board, a brick, a meter stick, a protractor, and books, but we were not allowed to use a scale. First, we used a motion detector to calculate acceleration. Then we moved the board higher and higher until the brick just started sliding. Finally, we used the angle at which the brick just started to slide to calculate the coefficient of friction. To start, we drew a free body diagram. The forces you have are the F normal, friction, and the force of gravity. But since the brick is on an incline, you have to take into consideration the x and y components of the force of gravity. The x component is Fg sine theta, and the y component is Fg cosine theta. You will need those when finding the F net x and the F net y later. Our angle ended up being 20 degrees. The most important equation in this problem is friction equals mu times the normal force. It will end up connecting your F net x and F net y. F net x and F net y will both be equal to 0 because the acceleration is 0. Acceleration is 0 because you are measuring the max angle before the brick begins to slide, or the angle where the static friction becomes kinetic friction. Now you write out the x component forces. That would be the x component of Fg sine theta, minus friction. This would all be equal to 0 still. Then you write out the F net y forces, which would be F normal minus the y component of the force of gravity, Fg cosine theta. This would also be equal to 0. Now you can make F friction equals Fg sine theta and F normal equals Fg cosine theta. This is where the original equation comes into play. We know that friction equals mu times the F normal, so you can replace friction with mu F normal so that we can introduce mu into the equation. Now we combine F net x and F net y because we know that Fn is equal to, because we know what F net n is equal to. If we replace Fn in the F net x equation, we get one equation where we can solve for mu. The Fg cancel out on both sides, so you're left with sine theta equals mu cosine theta. Then divide both sides by cosine theta. And since sine over cosine is equal to tangent, you end up with mu equals tangent theta. In our case, we ended up with mu equals tangent of 20, so mu equals 0.364. Our mission was to find the max mu before the brick began to slide, and we calculated the static friction coefficient between the brick and the wood at 0.364, but the actual value is 0.6. This means that the percent error was 39.3%. Our percent uncertainty of the angle was plus or minus 1 degree, or about 5%. To achieve more results in the future, we could test sets of materials other than the brick and the wood, and run more trials with the motion detector to find acceleration.